So I know that some of you already have experience with R, so this might be a bit of a review for you, but just for people who have just installed RStudio and this is your first time opening it, I'll just sort of orient you to the RStudio workspace and we can go from there. So this is the main terminal that you would, work on scripts in. You can use something called Markdown, which if you use Jupyter is a bit like a Jupyter notebook. You can make these chunks that have text and chunks that have code, etc., and work from there, which is really helpful if you're doing an assignment or you want to write a document that you can share with people and have your sort of code interspersed with text and the outputs of your code in line. This is the main console, so if you're just running code but you don't want to save it in a script or whatever, you can use that. It'll also be where all your outputs come out and such. On the top right here, you have your environment, so that'll have all your data sets and other items that you've loaded into your current working environment. And this panel down here, you can is where plots will be generated. You can view the packages you have installed. You can view different help pages, browse through the files on your computer, and stuff like that. I usually just leave it on plots. Okay. Yeah, so again, if you have experience with programming, you'll already know this, but this hashtag symbol is used to comment out lines that are, comments on your code rather than code itself. And we'll just start by running this line, which I've already done. It's just library tidyverse, and this will just load in the package that we're using today. So I will talk briefly about tidyverse while you're doing that. It encompasses a bunch of packages that are mostly used for data wrangling, plotting, things like that. So ggplot2 is great for making different graphs. dplyr and tidyr and stuff have a lot of great functions for sort of data wrangling that we'll go into in a little bit. But yeah. Okay, does everyone have the package loaded? Okay, I'll give you a second.
Can you remind us how to run a line?
Yes, okay. So you can either use the run button here, you can see that, right? Or I don't know if it's different on a PC, but on a Mac, you can press command and return at the same time. So command and enter. And yeah. And that'll run either the line you're on or the chunk of code that you've highlighted. Okay, so you can do it in the terminal, or you can go from tools, install packages, and just type tidyverse in there. It'll come up as your type. And you can install from there and then load in the package. Cool. So again, if you're already familiar with other programming languages, you'll know this already, but you have to install a package before you can load it in. So you can't just type library tidyverse if you don't already have the package installed onto your computer. But every time you're opening an R session or starting a script or something, you'll usually have a session at the beginning where you're loading in the packages and things like that. Is everyone good for that? Good. Okay, I'll move on. So today we're going to be working with a data set that's already built into R, but I still wanted to give you a sense of how to read and write in data, so I'll just do that briefly. So since we're using a data set that's built into R, we're actually going to write the data to a CSV first, which normally you wouldn't do. Normally you'd be loading in data that you have as a CSV or TSV or whatever. But I'll just run this. So the file is called Swiss, and I'm just going to save this to. So here I'm specifying what I want the output file to be called. Here I'm specifying what I want to be written to a CSV. Okay, so I'm just going to run that, and then let's say I want to read that in now. I'm going to use the read.csv command and then type in the file path here. I'm just going to run that. And now you can see in the environment, I have this data frame here. And I'm going to show you a couple ways to look at the data frame in the console, but you can also just click on it, which is one of the really nice things about RStudio. And you can sort of get an overview. Well, you can see the entire data frame from there as well. So I'll briefly go over what's in this data frame just so you have a little more context as we're working through it. It's different statistics from different regions in France. So fertility is just a measure, a standardized measure of fertility. Agriculture is the % of males that are involved in agriculture as an occupation. Examination is percent draftees receiving a highest mark on an Army examination. Education is the percent of people who are educated beyond primary school. And Catholic is the percentage of Catholic people. And infant mortality is live births of infants who live less than 1 year. And these are all in mostly in percentages. So it's not super important, but just so you have some context for the data as we work with it. Okay, so I'll go over some basic data functions here. So one way we can look at sort of like the first few rows of a data frame is to do this. Maybe you can bring this up a bit. So yeah, that'll print out the first couple rows of the frame for you. You can see that this column is called X, which isn't super helpful or informative, but we will change that later. Okay, let's see. Oops, sorry. Another thing we can do if we want to look at just the column names is call on the names function. What else can we do? You can look at the data types, which is often useful if you're like there's some functions that will only take certain data types as inputs, and sometimes that can be really frustrating if like your input looks like an integer, but it's actually read by R as a string or something like that. So it can be helpful to use this str function to look through the data types that are in your data frame. You can also get,
Sorry, I didn't understand.
Yeah.
So what is SUR given? What is it?
It outputs this. So here's where I run it, and here's the output. So you can see that it tells you, for example, fertility is represented as a number. X, or like the regions, are represented as a factor with these 47 different levels. So that's 47 different regions, separate regions that are represented in the data. You can see the data types that are represented for other columns here. So examination is an integer, education is an integer. And that's useful when, as I mentioned before, there's some functions that will only take certain types of data as inputs. So if you're trying to run a function that requires, for example, an integer as a data format, but you have it represented in your data as a factor or string or something else, you'll need to convert it into the right data format before you can run that function. You can also get a summary of your data, that. So this is a really helpful function that I actually use a lot, just to sort of get like descriptive statistics on your data set before you start any analyses. You can make sure everything sort of looks right. So it gives you the quartiles, the min, max, and mean and median of all of your columns for which that makes sense. Yeah. Everyone following so far? Yeah.
If you want to know what string gets as input, for example, that STR function,
Mm-hmm.
How can we look what is the inputs that each function?
Yeah. So I can go over that. I think I had that maybe a little bit later. Did I? Okay. I can do that here. So one way you can look at like the documentation for a function, is that what you're getting at sort of? Yeah. Okay. Is to do like the question mark and then the name of the function. So let's say we want to look at str. So it'll come up in this like panel here, and it tells you sort of the arguments that it takes. Obviously, a lot of these are like optional because I didn't type that many things in there. But yeah, that kind of gives you an idea with like examples and stuff like that. So yeah, that can be really useful. If you're using RStudio and not base R, you can also, I think, just search from like here. Like you can use this search tool. They have like links to a whole bunch of other things on like, I don't know, like R cheat sheets, data import and export, and like different packages and stuff like that. So it's pretty easy to access from RStudio. So you can do this with any function from the terminal, from the console as well. So like if I wanted to learn more about the summary function, I can run that and that'll pull that up. Everything good so far? Yes? Cool. Okay, so I will talk a little bit about Tidyverse, which I think might be new for some of you who already use R. And if you don't, it's a good way to keep your syntax a little bit cleaner than base R, especially when you have like very complicated like functions nested within functions and things like that. So the main difference between classic R and Tidyverse is the pipe operator. So I won't run anything just yet, but I'll just type this out. Where you do that. So that's what it looks like. It's a percent sign, a greater than sign, and then a percent sign. And this is not necessarily unique to the tidyverse, but I would say the tidyverse packages are the primary place in R where they're used. So in classic R, you apply functions by wrapping them around objects, right? So this would look something like, this is a real code, but just pseudocode. So you would write something like that, right? And that's what I've done up here. So I've called the head function on data, names on data, str on data, summary on data. And I'm wrapping that inside the function. So the difference in tidyr is that you sort of specify the object first, and then you send that to the function via a pipe. So that would look something, again, in pseudocode like, okay, you can, sorry, turn that down. So this is really good when you have like, again, like nested functions. So you're applying a function and then you're applying another function to whatever you've done inside. So instead of having like a billion parentheses, you can sort of pipe things and have all the code in sort of different lines, and it's a lot more readable that way. Let me see if I want to say anything else about that. I don't think so. Okay, so I'll move on to some of the data wrangling stuff, and we can start sort of using some of these pipe operators and some of these tidyr functions and seeing how the code looks different depending on whether you're using classic R or tidyr. Okay, so say we want to select specific columns in the data. Sorry. Yeah, okay. So in classic R, we would do something like select data. Let's say we want to select education, Catholic, fertility. So this is a classic R example of that. And so how do you think we would represent this in tidyr instead? Does anyone want to try, or should I do this first one? Okay, I can do this first one. So in tidyr, we would start by specifying the object. So that's the data frame. We run this pipe operator, and then we call the select function. I'll run both of these, and you can see that the output is the same. So here, I'm selecting these 3 columns. And again, if I run it, the tidyr version, I get the exact same thing.
What is the shortcut for running one?
Oh yeah, sorry, I think I said that maybe a bit earlier. So you can run things via the button up here, or the shortcut is the Command Enter button on a Mac. I forget what it is on a PC. Maybe it's like Control or something. But yeah, and that'll run either the chunk of code that you've selected or like the line that you're currently on. And you can also use select to choose everything but a specific column. Oops, okay. And to do that, I'm just going to do this in tidyr. You just use the minus sign here. Here I put this minus sign, so that's going to select everything except for the education column, and I'm just going to run that. And now you can see I've got all of these other columns, but it's removed the education one. Okay, so I mentioned earlier that there's one column here, up here, that is called X, and that's not super informative, right? Like, that's not something you should call a column in a data frame. So let's say we want to rename that. So in classic R, we would do something like this. Yeah, of course.
So with that line, data pipeline selected,
Yeah.
whatever, you're not putting it into a variable, are we?
No, no. So if you wanted to save it back to like, so let me show you. If I run data again here and I just look at it, you can see the education column still here. Yeah, that's a great point. So if you wanted to like remove it from like the item you have and not just do like a certain operation and then without changing the data frame you have loaded, then you would just run it like this. But if you wanted to like change the data frame and like remove the education column permanently, you would run it like that.
Put it in new variable, new name.
Yeah, or like,
Yeah.
so like if I wanted that, I would do this. And now you can see that I have this new data frame in my environment. That's data without education. There's now 6 variables instead of 7. And if I open it up, you can see that the education column is now missing from it. Yeah, that's a great point. So I'm showing you most of these things just like in the, like without changing the data frame itself so that we don't have like 1 million data frames created with like different columns in each one. But yeah, like if you wanted to remove them, you would do that. But I find a lot of these dplyr functions like group by and some of the things we'll get to later also really useful just for like examining your data without actually like saving it to a separate frame. Okay, so here I am, oh, sorry, I'm doing this in Classic R. Okay, so I will do that. And now you can see if I open up the data frame, the X has been renamed to region. Yeah.
So it worked, but shouldn't like region X be the other way around?
Yeah, that's what I thought. So when I was making this, I actually kept getting errors because I was doing like X equals region because that's what is intuitive to me. But after looking through the documentation, it's actually the other way around, which is for rename specifically. Yeah, not generally in R, which is why that tripped me up too. But that's a good point. I'll write a little note in here. Note that the new column name comes first in name. Yeah, so that is definitely confusing, and I don't know why that's like that, but it is, and now you know. So if I wanted to do this in the like tidyr syntax, I would do, oops, sorry. I would do that instead. Yeah, like I didn't mention this, but I have this as like this finished code as like a R Markdown file that I can send to Lena, and I'm sure she can like share that with everyone. So don't worry if you like don't write all the notes down or something like that. Like it'll all be posted. Okay. So now let's try subsetting some data. Okay, so I'll do this. I think this is the last one that I do both in Classic R and tidyr, just to give you a feel for sort of how it looks different and how, if you're, for example, already familiar with Classic R, like I was, I think showing you both ways maybe gives you a better sense of like how to translate from Classic R to tidyr and how to interpret code that you see in tidyr if that's new to you, but maybe like you're already familiar with the sort of traditional way of doing things in R. Okay, so let's say I want only the values, the columns where the value of Catholic is over, oh, sorry, less than 20, and where examination scores are equal to 15. So note here I'm using the double equal sign, and that's what you would use when you want to like evaluate a statement. So you're not assigning the value 15 to examination, but you're saying that you want to pull out the rows where examination is equal to 15. So I'll run that. And you can see there's only 3 regions where that's true, where examination is equal to 15. That's not a very good way of highlighting that. And Catholic is less than 20. And if I wanted to do this in tidyr, I would do, you can see that gives me the exact same thing. Lena, do you normally have people do like exercises or just like?
Yeah, that's you.
Yeah, okay, cool. So if you guys want to try an exercise, we can try, why don't you try to write code that selects the rows where agriculture is greater than 20 and the value of the Catholic column is greater than 50. I'll give you a second and then maybe someone can tell me the answer or I'll put it up. Yeah.
Is there specific data?
Yeah, so it's the Swiss data file. Let me go up briefly and you can,
Sorry.
oh, no worries. Yeah, so you can just read it in like that. I think that actually you can just do this too, because it's a data set that's already built into R. So
Okay.
if you run that, it should also work. Okay, so why don't you give that a go and let me know when you are done. So yeah, R has like a number of built-in data sets that you can work with. This like Swiss data set is one. There's also like the iris data set that's very popular in like machine learning and Python as well for like teaching. And there's a couple other ones. Iris, like the flower, so it has like data about like the different like petal lengths and widths of these like different iris like flower types and stuff like that. Did you load in the data okay?
Yeah, I'm just working on it right now.
Okay, cool. Has anyone finished this and wants to tell me what they did? Or you would like to sit in silence until I give you the answer? That's what I would do, so like I feel it, it's fine. Okay, cool. Why don't I at least get it started? I actually didn't write an answer for this, so we're just gonna do it together. So it's pretty much quite similar to the line of code I have. Why am I pointing at this? No one can see that. The code I have up here, right? So I'm gonna filter for values of agriculture that are greater than 20, and values of Catholic that are greater than 50. And you can see I get 18 regions where those conditions are true. Does everyone follow that? Like, yes? Like, what was the trouble you had trying to come up with this code on your own? Sorry, does that put you on the spot? Nothing?
No, it wasn't a problem.
Okay, cool. So everyone gets this? All right, great. So up until now, we've basically been running like,
I have a question.
yeah, of
I was
course.
checking out filter in the help section.
Yeah.
So, it's not coming up. Oh, okay, so it's like that for you too?
Yeah, so I think if you go to the dplyr package, and then you can click filter from there and it comes up. So I think if you wanted that from here, you would have to do like, oh, maybe not. Okay, well,
Are you doing that? Where'd you put it? I was
no worries. Okay, so I tried to do that.
Yeah.
Nothing happened, but it did come up with this, right? Do you get that as well on yours?
Yeah.
Cool. Okay, so I just clicked this and it took me to the dplyr one. So I think the problem is that there's two functions called filter. So you can see that here, one is this one from the stats library and one is this one from the dplyr library. So it doesn't know which one you're looking for when you type filter, right? Like you could be looking for either. So it just shows you both and then you click on the one for the package that you're using. Is that good? Okay. Yeah, so up to now we've mostly been running just one function at a time. So the like benefit of using dplyr might not be super clear, right? Like these lines of code, like in classic R and tidyr aren't like super different. And it's not clear that like this line is any, more succinct or readable than this line in classic R. But I think as we start to like chain functions together, you'll see how tidyr sort of makes things like more readable. So let's try that. So let's say I want to filter for rows where Catholic is greater than 20. And I also want to sort the data. So you can use the range function for this. And when I run this, you can see that I have filtered out for values of Catholic that are greater than 20, and that I've also sorted the data frame by education. So it starts from 2, goes up to, 53. Yeah, so let's see. You can also use arrange to sort things in a descending order, and that's just by adding DESC in there. So I will show you that. And you can see that I have the same thing, but education is sorted in a descending order instead of ascending. And that's just this bit here. So adding this DESC for descending before education. So I think this maybe sort of shows you how things are a bit clearer. Okay, cool. How tidyr can sort of help make your code a bit cleaner. Instead of having functions that are like nested within each other, you can have them as these separate sort of entities and like arrange them in different rows or whatever, so that they're not like running off the end of your line. Okay.
So like
Yeah.
if this was a classic R, you'd have
Yeah.
to assign it to data and you go next line and next line. Or,
I think you would have to do it in 2 lines, right? Like you'd have to filter first and then sort it after. Like I don't know that you could wrap those. And you'll see in other functions, there are ones where you can do it in like 1 line of classic R code, but you end up with like functions nested within each other. So yeah, like in both of those cases, it can be sort of either clearer or more efficient to do it this way instead of having like a line of code where you filter them out and then a separate line where you're like sorting them or stuff like that.
so if we load tidyr,
Yeah.
we can literally use this kind of logic and coding anywhere in all of our functions.
Yeah. So Tidyverse encompasses like a bunch of packages that are sort of in this like universe. So that's like dplyr, ggplot, and like a bunch of others. But you can also import those individually. Yeah. And I should mention too that like this like pipe operator is built on the library called, you don't have to load this. Oh, how do you spell this? I don't know how you say this, Magritter. So if you want to do what you were mentioning and use this operator with like other functions, you might have to load in this package as well. Like functions that aren't a part of the Tidyverse network.
I see.
Yeah. I'm not sure actually, but if you have problems with it, then if you import this library as well, sorry, this package as well, that should take care of it. Okay. Okay, so why don't we try an exercise where you get the top 10 values for agriculture. I'll give you a few minutes and then we can go over it. Here we go.
Can you use head?
Mhm.
And it will display the-
You can use head, yeah. So I'll give you a hint that you probably want to use something like this to sort the values.
you said the was descending.
Yeah.
Why do we need a range again?
So a range is the function that actually does the sorting, and descend here is specifying like that you want a descending order. So when you want ascending, you don't have to type that anything really, you just do a range. Like the default is to do it in ascending order.
Descend is not a function.
Yeah, it's a little bit weird that it takes it as like a function instead of an argument. I don't really know why that is, to be honest. Okay. Has everyone had a chance to try / do it? Okay, so I'll start putting the answer or my answer up. With all of these exercises, there's like more than one way to do this. So if you've done something different, don't feel like you've done something wrong. If it works, it works. So first, I'm specifying that I want to use this data object as my data frame. I'm going to sort the agriculture column in descending order because I want to get the top values. You could also do ascending and then call like tail instead of head, which is what I'm going to do. But as I said, there's like many ways to do these things. And to specify that I want the top 10 rows, because I think head by default prints like 5, 6, something like that. I'm just going to put a 10 in here. So when I run that, do this. You can see that I get the top 10 regions where agriculture has the highest values in the data frame. Yeah.
I was trying to index it without using head, like using the brackets.
Mm-hmm.
I'm not sure, I'm still not good at using it. Can it be done?
The indexing? I think so, but I think it is like cumbersome in R more so than it is in Python. And I'm not sure how you would use that in combination.
Yeah.
Oh yeah, I think you could, but yeah, I'm not
It's
sure
still
exactly
head,
how you would do that.
This bracket, and then like.
Yeah, did that work for you? Like,
Yeah,
or
it
did you get
is.
something close? So you had it like, what, after this?
Yeah, I couldn't remember if I could, I should put it as the first value or the second one for selecting rows. I think it's the second one.
Yeah.
But it is.
So you had like square brackets?
Oh, no, I put after the second
After.
height, but, oh,
Um,
I'm not sure.
yeah, I'm not sure. I can, yeah.
Head and tail are easy, but what if I wanted
like the middle ones, yeah. I can look into that and get back to you later if you want. Yeah, I know there's like a way to do it. I just like forget. Yeah, of course.
So this gives us the whole data frame.
Yeah.
My interpretation of your question was if you want the 10 values for agriculture column.
Oh, just the column? Okay, so if you wanted that, you could then do, I mean, there's a lot of ways you could do that, but filter. Oops, what did I do? Maybe you can't do that. Maybe this will work. Oh. Sorry, let me a second.
Can't you just use select?
Yeah.
You say like.
Yes, oh, sorry, I thought. Here you go. Yeah, thank you, that's great. Oh yeah, sorry, filter is when you have like a condition that you're trying to meet, and select is when you're selecting a column. Yeah, I get mixed up sometimes because the names for some of these things are not always intuitive. Like arrange, I always thought was like sort. I feel like it used to be sort and then now it's not. So I like always try to call things that are not actually real functions or are different functions from the things I'm trying to do. But yeah, it's fine. What else do I have for you guys? You have 15 minutes left. Okay. So another useful one is mutate. So you can use this to create new columns, especially if you want things like a new column that represents the average of a value or something like that. So let's do that. So let's say that a lot of you are graduate students, so I assume you have your own data, and let's say you want to mean center that data for some kind of analysis later on. So I can call on mutate. I'm going to call my new column mean center, let's do education. And I'm going to set that to be equal to the value of education for each row minus the mean of education.
Equivalency or assignment?
It's equal to, sorry, it's assignment. So it's one equal sign because I'm saying that this new column is going to be equal to this calculation, right? So that's the value minus the mean. And let's save that back. So now I see that I've got an extra variable, right? So I was at 7 before and now I have 8. Nope. Sorry, I'll go back to this code in a second. I'll just show you quickly that I now have this new column called mean center education. And that's the, well, as the name suggests, the mean centered education value. So that's each value of education minus the mean of that column. And I'll go back to this code in case you were still typing. Yeah. And the reason why it didn't like print out the output here is because I've saved it back to the data column. So I've actually changed the data frame and I've added a new variable of it, as you can see in the environment that it now says like 47 observations of 8 variables instead of 7. I think I have a couple other examples of that. Oh no, okay, I have an exercise. Okay. Is everyone good with this? Can I move on? Yeah, okay, cool. All right. So why don't we try another exercise where we create a column that represents the percent of participants. So I'll mention again, maybe I didn't mention this before, but the Catholic column is the percentage of people who are Catholic as opposed to Protestant. So they're assuming that those are the only 2 religions in Switzerland. Okay, so I'll give you a couple minutes.
So I forgot, for example, that Catholic was with capital C or not. The quickest way is just to look at the.
I mean, the easiest way probably is to like click it and look, but you can also do like, I think it was names. Is that right? Well, let's try it. You can do that, yeah. But yeah, like it's often like easiest, I guess, to just like click on the data frame. The only thing where that often isn't the easiest is if you have like a huge data frame. If you like just want to look at the columns, like I have like a set of tweets that's like almost 1 million tweets or something. So like when I click this, it like takes a really long time to open it up. And it's like really hard to like scroll through it or something like that, right? So if you're doing something like that where it's like a huge data frame, but you don't actually need to load the whole thing, like you just want to look at the column names, you just want to like look at a specific rows or columns, that's another place where like these functions and like some of the dplyr functions too of like selecting things or whatever come in really handy, because you can just do that instead of like waiting for minutes for this giant data frame to open. And also normally when you like start typing a column name, like it'll fill in things that it thinks you might be typing. So even if I type lowercase c, you can see what comes up here is like it shows me like Catholic with a capital C, right? And that's the correct one. So I can navigate that with the arrow keys here and then click tab when I get to the one that I want. So that's also useful if you like kind of remember what your column is called, but kind of don't. You can just be like data, oh, it was like something about Catholics, or like even if you don't, like all of them come up here, right? Like you can choose from that list. And that's just like an autocomplete. Like I didn't press anything to make that come up. It just like will. It's part of Tidyverse, so if you've loaded Tidyverse, it should be in there. Okay, so I'll start putting up the answer for that. So I'm going to call this new column Protestant, because they're assuming that if you are not a Catholic, you're a Protestant, and the Catholic column is a percentage. I'm just going to do that, right? So 100 minus the percentage of Catholics. And, oh, sorry, let's save that back to the data frame. So now you can see I have 9 variables, so that's created a new column called Protestant, and you can see when you're looking at it that it's like 100 minus whatever this value was. Yeah.
So while creating this, I was wondering, is there a way to take that column right next to the Catholic one so you tell R where to inject the column? Is that easier on the eye?
I think you can reorder, but I think you'd have to do that in a separate function. I'm not sure that mutate. Let me see. I think it like, well, maybe there is. Let's look. Yeah, it looks like it doesn't really take any arguments that would support that. Yeah, so you'd probably have to like reorder them after. Are there any other questions on that? Good, okay. Let me see what else I have. Okay, so I have a couple other sort of like functions that are useful for data wrangling, and I'll just kind of go through them. Oh, sorry, I'm not in the right place here. I'm still not in the right place. Okay, so there are 2 functions called gather and spread. For those of you who have used R before and used like the reshape2 library, this is sort of another version of that, / maybe its replacement. So it's basically a way to transform your data between like long and wide forms. And if you're not sure what that means, I will go through it. So let's start by gathering. So if I run this, you can see that it has taken the fertility column and changed it so that I now have a column called fertility and the values in a separate row.
Yeah, that makes long form.
It makes wide data longer. Yeah, again, this is one of the ones where the names are like not intuitive. So every time I'm like, wait, is it gather or spread that does it? Yeah, so I will go through, I think I have an example of this. Another example. And you can see that where I have like measure and value, that's what these columns are called here, right? So I'm saying that the measure is called fertility and the value is the value of the column that used to be called fertility. Oops, I forgot what this does, so I'll find out. Okay, so this makes it like completely long form for everything except the region column. So it's taking all of my variables and changing it into long form. And so that maybe gives you a better sense of when you would want to use this function. Like normally you don't want to transform like just one column, right? That's not like super useful. But if you have like a bunch of columns and you want to transform that wide form data into long form, that's where the gather function can come in really easy. And you can like call this like and assign it like that or something if you're using it for some kind of like statistical analyses where you need your data in long form.
I want to transform everything.
I think you just run like this.
You should have a paper.
Sorry? So yeah, you would just run like just measure and value, and that takes everything.
What kind of stats do this? this? I've seen it before. but I've never
So
used it.
I do this for like mixed level models.
Mixed in your models?
Yeah,
Oh,
yeah. But it really depends. Like it also depends on how your data is initially structured, right? So I have ones where like I, for example, have these loadings for like tweets on different moral foundations, but maybe I want all those moral foundations in one column called like moral category or something, and all the loadings in a neighboring column, instead of having like a bunch of columns with the foundations as the column names and the values beneath, if that makes sense.
I get the picture. I've never used it, so I guess once I use it.
Yeah, so I use it with like the Elmer function. That's part of LME4. Yeah, but yeah, it depends a lot on how your data is structured, right? Like you might already, that might not make sense for your particular data. You might already have data that's like in the correct format for that. But yeah, for like various statistical analyses, it's sometimes required to like transform your data in certain ways. Yeah. So if I wanted to spread that after making the data, so the first part of this code is what I ran up here, right? And that made fertility into this like weird thing with two separate columns, where one was called measure and had fertility all the way down, and one was called value and had all the values separately, right? So if I run spread after that, I know this is like kind of a dumb example because I'm like doing it and then taking it away, but just so that you get an idea of like how that works without me making like a bunch of different data frames. If I run spread measure value, it'll change that back, right? So now instead of having that, I have like a regular fertility column like we did before we ran that code. So the spread function makes long data wider. Does that make sense? Okay, so we have a couple more minutes, so I'm gonna like just sort of move through the last few things because I think these are often like useful for people doing like statistics and stuff. Let's see. So let's say I want to find the mean of each variable. So first I would select out the region column because it doesn't make sense to find the mean for a column that's like names of regions and there's like one row for each, right? And then I'm going to make it into long form. I'm going to group by measure column. It doesn't make sense. And then I'm going to use this summarize. I know I'm going through this a little bit fast, but I'll have the code posted. I just want to like make sure that we get through this so that you sort of have an idea of how you could do something like this. Okay. Yeah, so that, sorry, this like printed out in scientific notation for some reason. You can change that. But so this will spit out like the mean for each column. That's another way where you might want to use like these gather and spread functions if you're like want to manipulate your data to calculate sort of different values amongst them.
Can you
Yeah, so I'll go through this. So here I'm taking out the region column because it doesn't make sense to calculate a mean on the region, right? Like those are the names of the different areas. And then I'm converting it to long form. So we did that a little bit further up. That was the one where like it's entirely in long form, right? So you have a measure column that has all the column names now in long form, and then a value column that has all those values. And then I'm going to group by the measure column. So that's going to group all the values that have the same measure. So like all the fertility values, all the education values, et cetera, all together. And then I'm going to summarize that by taking the mean of the value column on this grouped data. And yeah, sorry, I don't know why it printed out in this format. It like didn't when I did this at home. So that's the one mishap of this workshop. That's not too bad, I guess. So I was going to have you do this as an exercise, but maybe I'll just like write the code since we're running out of time. So say I wanted to create a column with the median of the Catholic column and remove some other things. So this is just sort of like a way to show you like ways that you can combine these functions to manipulate your data frame in code that's like still fairly readable. So I'm like doing a bunch of things, but let's say I wanted to take out the education and region columns. And I only want the fertility values that are greater than or equal to 50. And then let's say I want to create this median Catholic column that's median Catholic. So you can see I've like created this new variable. I've like filtered all these data frames. And I think this is one of the cases where you can see how the code is like a lot more readable in this tidyr format. Like you can see sort of every individual step of the things I'm doing instead of having like a bunch of lines of code, like separate lines of code. And these pipe operators sort of like separate everything neatly. Okay, so does anyone have any questions? Good. Okay, I'm happy to like stick around for a bit if you have questions that you don't want to be broadcast live or whatever, or put on YouTube for all of eternity. But yeah, all right, cool. Well, thanks so much. I hope you learned something.